Okay guys, in our last video we looked at matrix multiplication in general, and specifically what we looked at was a case where we took a 2 by 2 matrix times a 2 by 2 matrix. And while this is very good in all, what I want you to know is that not everything is very much cut and dry like a 2 by 2 times a 2 by 2, where we would say, first of all, it's defined if and only if the inner dimensions match, but second of all, the size of our answer would be the outer two dimensions here. We would just get some new product here that would itself be a 2 by 2. So I feel like it'd be important for us to look at some cases in which we multiply different order or different dimension matrices in which it still works, and then talk about the size of our result as a result of that. So we're going to take a look at these three examples that I've got listed here, all matrix multiplication. And so what I want to do is I want to get this kind of down to a science. And so starting with this, in terms of how we do matrix multiplication, we could list a set of steps here, but what we do first of all is write the matrices side by side. So let's see if I can get this to show up here. Try again. 1, write the matrices side by side, and then determine whether the inner dimensions match. Okay. The thing here is this. Remember, matrix multiplication is only defined if the inner dimensions match. And we say if the inner dimensions match, then write your product matrix that has the outer dimensions as its order. So we're just going to start with these two steps right here. As a matter of fact, whenever we do a multiplication problem, that's the very first thing we do is we say, can I write it side by side, and can this even be possibly defined? And so in this example you see up here for letter B, it looks like we have 2 rows and we have 2 columns. Here we have 2 rows also, but this has 3 columns. And so certainly we'll assess the situation by saying, look, we can do this because our inner dimensions match. Now the second thing we know is that our outer dimensions here are going to be the size of our answer. And so what I'm going to do is instantly I'm going to build in this answer matrix here that I know has 2 rows and 3 columns. Now I'm going to try to give myself plenty of room here, but when you do this 2 rows and 3 columns, you want to give yourself some space, because remember what we're going to be doing is multiplying and adding. So the very first thing we did was check for compatibility, and the second thing we did was populate an empty product matrix. Now with the remainder of this, what we're going to do is, and let me get my text tool back out here, see if I can go in orange. Perfect. We are going to determine the position of the entry that you are trying to find in the product matrix. Okay, so what we're asking for is really the row and column. And then what we're going to do is this. We're going to multiply that row in the first matrix by that column in the second matrix. That row in the first matrix by that column in the second matrix. And then we're going to simplify that value to get a final value. All right, so all of these steps that we're going through here, what we're going to be doing essentially is just this idea of finding, well, where is it that we want to find first, and what row and what column is that in? We're going to multiply that row by that column. So looking at this up here, we would say, well, the first thing I want to find is it's this entry right here, and it happens to be in the first row in the first column. So the way this works, remember, is this. We're going to take the first row in our row matrix here times the first column in our column matrix, and we always start at the beginning of the row and in the top of the column, and we multiply these two values. So in this case I get 0, but then we work from left to right here and top to bottom here. We move over to the 1 and down to the 2, and we multiply those as well. So I just don't want to write too much here before I can undo it. We would say, first of all, we take 0 times 0, starting at the beginning of each row and each column. We say 0, plus now we're going to move over in the row and down in the column here. We say 1 times 2 is 2. And so in terms of our final matrix here, we're going to simplify that. We get a 2. Now looking at this next entry, this is first row, second column. Excuse me. So we're going to take the first row times our second column. And so I'm going to unhighlight these just so I have some room for the next one. But we say 0 times 3, we get 0. Plus now we'll move over in this row, move down in this column, 1 times 1, which is 1. So we get 0 plus 1, which is 1 here. Okay, on to the next entry here, which is in the first row, third column. We're going to take our first row times our third column here. So starting at the beginning of the row and the top of the column, we say 0 times -2, which is 0. Plus now we'll move over in the row, move down in the column, we say 1 times 4 is 4. So we get a 4 here. So that's our first row. Now we're going to go through and work on our second row entries. So second row, first column, second row, second column, second row, third column. So second row, first column. This time we're going to take our second row in the first matrix times our first column in the second matrix. So in this case, starting at the beginning of the row on the top of the column, we say 7 times 0, which is in itself 0. Plus now we're going to move over in the row and down in the column, and we say 2 times 2, 4. So 0 plus 4 is 4. Let's pick this up a little bit here. We say now second row, second column, we're going to do our second row times our second column. So we get 7 times 3 plus 2 times 1. So 7 times 3 is 21, plus 2 times 1, that'd be 2. So we get 23 here. And then our last entry is in the second row, third column. So starting at the beginning of the row on the top of the column, we say 7 times negative 2 is negative 14 plus. Now we'll move over in the row, move down in the column, we say 2 times 4, and we get 8. And so negative 14 plus 8 is a negative 6. So this would be our matrix product in this case. And what I want you to notice is we didn't have to take a 2 by 2 times a 2 by 2. We could take a, say for instance, a 2 by 2 times a 2 by 3. As long as the inner dimensions match, we can do this. And the size of our answer is always dependent upon our outer 2 dimensions here. So taking a look at letter C, I like this as an example because to do all these steps here, the first thing is we write them side by side and determine whether the inner dimensions match. Well, our dimensions here are 3 rows by 2 columns. And then this matrix here has 2 horizontal rows, but only 1 column. So we get a 3 by 2 times a 2 by 1. So in this case, we can take a 3 by 2 times a 2 by 1 here because the inner dimensions match. And then the size of the answer that we would get, well, it would be a 3 by 1. So what would a 3 row, 1 column matrix look like? It would look like this. It would have 3 rows and we'd have just 1 column. And I want to label this here. So now that we've got this filled out, we're just going to go through picking out entries at a time. So first row, first column, second row, first column, third row, first column. So we'll just go over here, first row, first column. We'll take our first row times our first column here, starting at the beginning of the row and starting at the top of the column. So we get 2 times 3, which is 6, plus now we'll move over in the row, move down in the column, 1 times negative 1, which is negative 1. So our answer would be a 5 here. I'm going to say 5. Okay. Now second row, first column. So second row, first column, we get negative 4 times 3, which is negative 12. Plus now, we're going to move over and move down. We say 0 times negative 1, which is 0. So we get negative 12. And then last but not least here, we have third row times first column for our third row, first column entry. We say 1 times 3, which is 3. Plus now, the next thing, we'll move over and move down. We say 3 times negative 1, which is negative 3. So we get a 0. Excuse me. So this is our 3 by 1 product matrix. So for our last example, just looking at letter D down here, let's do the same steps again. Start by writing them side by side as we have them, and then write out the dimensions. So each of these, it looks like they have the same order. It looks like they have 2 rows and 3 columns. So 2 rows, 3 columns. And this is also a 2 by 3. So my favorite thing happens here. What we get to write is this, undefined. And the reason why is because we have an inner dimension mismatch. Okay, and whenever we say inner dimension mismatch, we basically mean to say that these things couldn't be multiplied because their inner dimensions are not the same. So we could stop right there and just be done with this. So again, when you want to multiply, write them side by side and determine whether you can do it in the first place or not. And if you can, then write your blank product matrix, because we're going to chase after individual entries one at a time by knowing what row and what column that entry is in, and multiplying that respective row by that respective column in our first and second matrices, okay? So in the next video, we'll take a look at what would happen if I multiply 2 matrices in different orders when I get the same answer. Cheers.